Good morning, friends. I am Chaitanya Mangrulkar, and today I am discuss about electrical motor. So, what is an electrical motor? It is an electrical machine which converts electrical energy to mechanical energy. Electrical motor can be powered by direct current, example batteries, rectifiers, and all, or by alternating current, such as power grid, inverter, or electrical generators. So let's talk about its component. It has field magnets, commutator, armature, winding, bearing, stator, and rotor. Let's talk about rotor. The dynamic part of the motor is a rotor that creates the mechanical rotation of the unit. The next is a field winding. It is made with the copper wire. The field winding circle around the slot carries by the pole shows. The next is yoke. It is an magnetic frame made up of cast iron or something steel, which works as a protector. The next is a pole. The pole have two parts, that is pole core and pole show. These two parts are fixed together by hydraulic pressure and are by attached to the yoke. The next is a brushes. The brushes with the commutator are working as a bridge to the connect the static electrical circuit to the rotor. The next is a DC motor commutator. The commutator is a split ring made up of copper segment commutator in the DC in another DC motor part. The next is a armature winding. The armature winding of the DC motor has two construction, that is lap winding and wave winding. Next is a stator. It is the DC motor part that receives the supply. So let's see geometric inner structure of the electrical motor. It is an geometric inner structure of electrical motor in which X pole shows magnetic field of the motor, Y pole shows the inner rotating rod in the motor, and Z pole shows the place of armature in the motor. So now let's see how does motor work. Do you know how an electrical motor works? An electrical motor converts electrical energy to mechanical energy. An electrical motor consists of rectangular coil of insulated copper wire. The coil is placed between the two poles of magnetic field. The end of this coil are connected to the two halves of that split ring. The inner side of this half are insulated and attached to the axle. That the external conducting edges touches to the conducting stationary brushes. The current in the coil enter from the source battery through the conductor brushes and that flow back to the batteries through the another brush. When we apply Fleming left hand rule to find the direction of the force on the current carrying conductor in a magnetic field, we find other force acting on AB pushes it downward, while the force acting on the arm CD pushes it upward. Thus, the coil mounted free to the turn and about axis to rotate anticlockwise. At half rotation, makes contact with the brushes X and P with brush Y. Therefore, the current in the coil reverse flow and along DCBA. The reverse of the current also reverse the current of the force acting on the two arm AB and CD. Thus, arm AB and the coil that was earlier pushed down is now pushed up. The arm CD previous by pushed up is now pushed down. Therefore, the coil and the axle rotate half a turn more in the same direction. The reversing of the current is repeated at each half rotation, giving rise to the continuous rotation of the coil and in the axle. So that is so like that the electrical motor works. So thank you.